Okay, guys, we are winding down. Okay, you guys, just 2 sections left. 7-2. So today we're going to do area under the curve. Tomorrow we'll be doing questions, maybe going over your tests, um, work time. It'll take me all hour to get through this. I'll get through this. We have one problem for tomorrow, as you can see. And then Friday, we're going to have a little quiz on area. The most important thing for you to be doing is to be working on that big AP packet that I just gave you today. And we're just going to do the area problems out of this. You're going to eventually do all of the parts, but for this week only, just A. And there's an assignment out of the book, but if you're going to choose something, choose to do this first. But the book assignment isn't so bad, and we'll talk about what that looks like. It's very minimal. Mostly we're going to give you AP problems to practice. We will not come back to this after a break. Maybe we'll come back to it on Monday and Tuesday of exam week if we need to, because this is a guarantee. It's a 100% chance, you guys, that one of these questions, is on the exam. Just very similar. Oh, they always change it up a little bit. We cover everything. So if you can do this, you got a good easy 9 points on the exam. That and the differential equations. Well, everything's always on the exam, but this is always going to be free response. You can't work through the whole thing. All you're going to do is the area problems. Okay, so that's where you really want to focus your energy. We have a little quiz on Friday, and we're going to take one of these area problems out of this packet, and that's your quiz. Okay? Out of this packet. So if you've done all the problems, you'll be in great shape. You're only doing A. And we have 3 days to get it done. Yes. A for all of them. And we got 3 days to get it done. Monday, Tuesday, and Wednesday, we do the volume piece. Then you'll be able to do the rest. Then Thursday, next week, you have a partner quiz. I want a problem similar to this or one of these. And then Friday and Monday are work days, and Tuesday, Wednesday are the test days. So it's really for you to be working on AP problems. But try and find multiple choice ones because I know they're there. Question? Yes, because you just go through and look at the AP stuff. That's 2003. Go through AP solutions. Everything's there. Now, most of this is going to be visual. Okay, Zach? It's going to be geometry. There's very little calculus. It's all geometry. So let's look at this. Let's see, remember what a differential equation is. I know Casey knows it. I got one that knows it. What's a differential equation? Okay, it's an equation involving derivatives. Yeah, but you'd be surprised how many didn't get that right. Okay, so you're going to have an equation. All these words are important. Okay, Stephen? It involves derivatives, so you're going to see a dy dx or something like that. And when you solve it, what will the solution be? It won't be a number whose solution is a function. So you have to solve for y equals. You don't have a choice. Okay. Okay. What about the next one? What is an integral? It is a signed area. We'll take this slowly today, and by the way, please interrupt me if you get lost in any of the geometry or anything. Doesn't matter. How do you find the actual area? What is it? What if I have this situation? I want to paint underneath this curve. I need the absolute value because this integral is 0. So it's the absolute value of the area, of the signed area. So what you're going to do is integrate from a to b of the absolute value of f of x. You do not know how to integrate an absolute value by hand. The calculator can do a definite integral. The CAS can do any of them, but that's not allowed on the exam. No. use the CAS on the AP exam. Well, yeah, we'll talk about that. We'll get there. And School Savers, I haven't checked it out. I just got an email, but I haven't had time to check it out yet. Is selling supposedly the Inspire calculators for like 55 bucks or less, which is really a good deal if you need a handheld. Yeah. I'll look it up. If it's decent, I'll put it in the updates on your Schoology page. What? Oh, you got the email? I haven't read it though, so I haven't gone to the website to see what they're selling. Plus, okay, you guys. Plus, if you want to get an 84 calculator that's in color, they have those. I was told they weren't going to have those till the fall. In color. The 84 is in color. Yes, we can do that. Tomorrow we'll have more time to do it, okay? You know what'll happen. Well, you can already on the iPad. Okay, so we're going to find area. You guys? Declan? We're going to find area and volume. That's what this chapter is about, and then we are done. Volume. So you can find maybe the volume of a football if we knew the arc, the curve. But let's just do area now. And so there's my function, and I want to find the area from x equals negative 1 to x equals 2. So I'm going to draw in a line. I can cheat. Okay, so you might want to draw in some boundaries there. There we go. And I want the area bounded by, even they don't say it, but bounded by the curve and the x-axis. It's always trapped at the x-axis. Okay, we're going to go back. We want to understand what's happening here. Okay, Jack? And we are going to draw in a rectangle, because that's how we found areas. Remember the Riemann sums? We found the area of a rectangle. And let's look at the area of the rectangle. What is the width of the base? It's the change in what? X. This is the geometry right here. Okay, Max? What is the height of my rectangle? You have an ordered pair there, X and Y. Which one is it? It's the Y. So the area for one rectangle is equal to the height of the rectangle times the base. This is height times base. So literally, that's what an integral is going to mean. That's why you have a delta x in it. It's the area of the rectangle. Well, guess what I want to do? I want to put a whole bunch of these in here. I want to put an infinite number of them. So I'm going to add up all the rectangles, and I'm going to take the limit and let n go to infinity. And some of you are saying, no, I don't want to do a Riemann sum. And you're right, I don't either. But Riemann said we can write this like this. Okay, you guys need to pay attention, because this is it. We only have like basically 3 lessons. I would say there's 3 lessons left. Area, volume by rotation, and volume by cross-sections. And then that's it. And then you practice and practice with AP problems. Okay, so I want to integrate the y value. Notice this is generic. I'm not even looking at what the curve is. I don't want to. From dx, I want to add them all up from, and where are we going to start here? X equals negative 1, 2, 2. Now, I'm very particular. I want to see the differential. On the exam, if you don't put the differential in, you're okay. That's only because they don't want to slow us down on grading. But the differential is what tells us what variable we want for our function. I don't want to see y there. I want to see what letter? X. So now, and if they say f of x equals this, you can just write in f of x. You do not have to copy it. But I'm going to copy it. So this is x squared plus 1. And now everything's set to go. So I want to integrate from negative 1 to 2, x squared plus 1 dx. And I really don't need the parentheses, because the dx and the integral symbol together mean those parentheses. Well, we're going to do one of these by hand, and that's it. The rest we're going to use our calculator. Now, on the solutions, check your solutions with what's online, because we don't really care if you integrate or not. Now, the problem is, if you don't integrate, if you're having problems integrating, then you probably better practice with it. Okay, so what's the antiderivative of x squared? X cubed over 3. So if you need practice, and some of you do, you probably should. Plus, antiderivative of 1 is x, evaluated at negative 1 to 2. Whose theorem is this? Thank you. I wish. Fundamental theorem of calculus. No, it means it's important. Do you know what the fundamental theorem of algebra is? If you have f of x equals x to the n, that most number of zeros you could have, either real and imaginary, is n. That's the fundamental theorem of algebra. The fundamental theorem of arithmetic is if I factor 12, for instance, there's only one factorization for that. So when you factor your trinomials, there's only one correct answer. There's no other choice. Those are fundamental theorems. This is the fundamental theorem of calculus, or the evaluation theorem. So that's going to be equal to 2 cubed over 3 plus 2. Okay, so I put 2 in here and in here. Then minus, I'm going to put parentheses here because I want to see it done correctly. So it's negative 1 cubed, because you know where you're going to make your mistakes? With the negatives. That's correct. And this is negative 1. And even I double check it because I can make mistakes with negatives. So this is going to give you 8/3. Somebody already said the answer, I think, plus 2. Then when I cube negative 1, I get a negative. Times a negative gives me plus 1/3. See that? Where's the calculus? The calculus is right there, right the integral. Oh, well, I'm finding the antiderivative, but if you use a calculator, then there's no more calculus there. And then this is a minus and a minus 1, so it's plus 1. So adding the 8/3 and 1/3, we get 9/3. Plus, and 2 plus 1 is 3, and so somebody said 6. Samuel, that's good. That's 6. 6 square somethings. I've never seen them. I can't ever remember seeing them do units on these, so don't worry about it. But there's always a first. Who knows? Okay, is that easy? They gave us x squared plus 1. The thing is you really want to draw the slice. I know some of you aren't going to want to do that, but when we get to volume, if you don't draw the slice, you're not going to see what's happening. That little rectangle. Now, I have to regraph this one because my picture is wrong. I don't know if your picture is wrong. Yes, your picture is wrong. So we're going to regraph that. So I'm going to get my graphing calculator out. You're going to want your graphing calculator today. And last class did not ask me why I knew that was wrong, because I can factor that, but I don't know if you know or were ever taught how to factor that. We factor by grouping. You always want to be in radian mode. Everything to the left should be highlighted, or dark, however you want to say it. Okay, so in y equals, I'm going to type in x cubed. Now, what's going to look different between my graph and yours will be our windows. If you don't have the same window, it won't look the same. 3x squared minus x plus 3. They give me the domain. If you are given the domain, you can do zoom fit, but I'm not going to do that because I don't really like it that much. I think I get a better picture when I figure out the window myself. And I'm not going to make the mistake I did in the last class. I just want to really go from negative 1 to 2. So I am going to take my window and make it go from negative 1 on the x's to 2. And on the y's, that looks like it goes up a little bit. So let's make them go from the y's. Let's go negative 10 to 10. That one comes out okay. And I could look at a table to see. They ready? Actually, you know what? I'm going to make it look more like that. Let's make this window, and I hopefully won't make the same mistake again. Minus 2. I always like to go a little bit beyond. And x max is 3, because I want to see the picture. Yeah, this one I'm going to pay attention to what I'm doing. Okay. There. That looks better. So I want the area. I want the area from negative 1, which is this. That's negative 1 to 1, and I want to stop at 2. Well, there's a couple ways to do that. This. We can do absolute value, but let's pretend we're not on the graphing calculator part of the exam. Now, this used to always be in the graphing calculator part of the exam, but there was a program out there that some students had that would actually set all of this up for you. So they put it in the non-calculator part. So for 2 years, and then last year they put it back in the calculator part. So honestly, I have no idea where they're going to put it. No, I don't even know what it is. We're better than that. We're going to do this because it's not that bad. No, I don't know what it is. Okay, we'll try and get some of that done. It takes time, though. Okay. Okay, you guys, I want to integrate. I'm going to integrate from, where is this? This is at negative 1. This is at what? 1. X cubed. We'll do this 2 ways. Minus 3x squared. Oh, I'm going too fast. Sorry. Put your little slice in here. Is that delta x? Is the base delta x? Yes. So the area is equal to delta x is the base, and the height is the y-coordinate. And because when you do your rectangle, the base and height are perpendicular to each other, they will always be different. So if this were a delta y, then that would be x. I'm not even looking at the function. Well, now I'm going to look at the function. So it's the integral of y dx. That's what I'm going to do. That's what Riemann says I can do, and then we have the fundamental theorem of calculus. So we're going to integrate from negative 1 to 1, this one over here to that one. And the y value, I could just write in f of x if I want. I don't have to write in x cubed. As long as it's clearly defined in your problem on the exam, you may just do this. And then it's dx. Because what happens? Yes, we have to do it separately. Okay, so that's that one. And then that's negative. So I want to integrate from 1 to 2 my f of x. I'm just going to do that because I'm running space. But what's true about the sign of this area right here? It's negative. I want to know how much paint I'm going to use. So I'm going to put a negative in there. And that's all you have to do. That's it. Could we do it? If we are given a graphing calculator, can we do this an easier way maybe? It is y. Y and f of x are the same things. And this y is this y. I just ran out of space here. And on the exam, as long as they tell you what f of x is, if they say clearly f of x is something, you can just write in f of x. What else could you do? Couldn't we integrate from negative 1 to 2 of my f of x? But then what do I have to do to make this work? That's not going to work. Absolute value. Problem is, I don't know how to integrate the absolute value of x cubed minus 3x squared minus x plus 3. I don't know how to do that. So I'd have to use a calculator, or I have to break it up into 2 areas. If this is in you guys, if it's in the non-calculator section, and you have to break it into 2 areas, they will give you the picture, or they'll make it something you know is obviously negative or whatever. Okay? So don't worry, they're not going to give you this function. You don't know where that is? They're not expecting you to be able to factor by grouping. So, should we do this on our calculator? Let's do that. I got. Hmm? Oh, I could. No, that'll just confuse everybody else. Well, I'll help you. Okay, so I just want the area. So on the Inspire calculator, you go to your it's values, I'm trying to think what it is, properties or something like that, and then it'll ask you to find area. So we're going to do this second calc, and we're going to find the integral 7. We're going to do the first one. So we're going to start at -1. And on the Inspire, just drag your cursor across. That's it. And then we are going to end at 1. Second, calculate, and it's the integral. It's kind of nice. -1 to 1. Now, when I do the next part, just so you believe me, we're going to do the next part. And we want to integrate this one. But what's wrong with this one? This is the first one's 4, but this is going to be what kind of a number? Negative. So we're going to go to second, calculate, 7. That's the integral. And we're going to start. I'm going to type in the 1. I want to get the right answer. And then we're going to go to 2. Not to 3. And there it is. And it's -1.75. Well, what's the problem? What do you have to do with this to make it work? You could absolute value, or you could subtract it. Either way, 4 minus a -1.75. So the answer is 5 points. I just took a picture of it. I wrote it down. Again, no, not unless well, I could. I'd have to redo it. So let's just do the integral from -1 to 2, which now represents the displacement. So I want to get rid of all that stuff. Second, draw. I want to clear my drawing. I could have done it on the main screen, but I'm going to do second, calculate. Integral is 7, and I want to go from -1 to 2. Is that number going to be bigger or smaller than what I have, or the same? There it is, 2.25. When you press enter, it should just come up. Okay? Now, we have two functions here. We'll call this one f of x, and this one g of x. And I want this region. That's A, that's B. Put in the slice. Let's see.
Casey messed it up.
Yeah, the area should be in there someplace. I just can't see it.
Oh, 2.27. Well, Casey changed the
Yeah.
limit, so.
Yeah. Okay, so we're going to find this one. Draw a slice. I think just touch the screen. Very nice. Okay, so we're going to draw a slice. Let's use a crayon. There's my slice. Okay, what's the base? Stephen, what's the base? Delta x or delta y? That's right. That's delta x. Okay, so the area for one of these is delta x. Now, how do you find the height? Okay, you guys? I want this length. find how that is. If this is up at 4, oh, I can't write with that one. There's no color with it. If this is at 4 and this is down here at 2, how tall is it? It's 2. You go 4 minus 2. So what are you going to do with this function? And this function, you're going to subtract them. So it's y1 minus y2. I'll figure out which one is which. Delta x. That's the calculus. Setting up the integral is the calculus. The rest is algebra. So we integrate, and we're integrate from where to where? A to b, because those are the x's, and my differential will be dy or dx? Dx. And it's y1 minus y2. Which one's the top curve? G or F? It's G minus F. Just geometry. If you're okay with geometry, you shouldn't have too much of a problem. I don't know what the functions are, so I'm done. That's all you do. It does matter, because which one's taller? Yes, because I want this to be a positive number. Let's say on the exam you reverse it, and you come out with a negative number on your calculator, and you're looking at the clock and say, I don't have enough time. Just put a negative in front, fix your negative over here, and we'll work. So if you do it in the wrong order, as long as your math is correct, you're okay. What? You could do that too. Okay, here's now a real problem. I want to find the area bounded by those two curves. So I'm going to bound it by this line. That's y equals x plus 4. And on the bottom, this curve. That's y equals x squared minus 2. So when I draw my little slice in there, this part won't bother you because it's a positive minus a positive. But what about this? Is that going to take care of itself? What's the base? Delta x. How do you get the height? I want this complete length. It's what? It's this value minus that value. So it's y1 minus y2. Start on your page. Okay? Do you guys see that? Now, what's true, if this is up here, 1, 2, 3, 4, and this is at negative 2 right there, how tall is it at that point? It's 6. How do you get that? You go 4 minus a negative 2. So don't worry about the fact that this graph is underneath the x-axis. It will take care of itself. Okay, you guys ready? It's y1 minus y2 times delta x. So we're going to integrate, and this is going to be a problem, because I don't know where they are, but it's y1 minus y2 dx. What do you want for your variable, x or y? Can never change the differential. That's fixed. So I don't want a y here or a y there. I want to know what they are in terms of x. Okay, which one goes first? The line. X plus 4, I heard. It's higher up. Bigger number minus smaller number. The smaller number is the parabola, which is x squared minus 2. This would be a non-calculator type problem because you could do it. So absolute value will get you in trouble because you can't integrate that because I don't know how to. Now, where's the next problem I have? I have to know the x values where these curves intersect. So what's true about the y coordinates at this point for both these functions? What's true about the y? They're the same. So I'm just going to set these guys equal to each other. And it's not any harder than this. Because what's true about their y coordinates here? They're the same. I need to figure out what the x's are. I could find y's, it doesn't matter. Now to solve any equation, Stephen, we set it equal to 0. Let me say that again. To solve any equation, you set it equal to 0 because then you can use zero product property. Can't use zero product property unless it's 0. So it's x squared. Now I want to get the x to the other side, so it's minus x. Minus 2 is already there. Putting the 4 to the other side becomes minus 4 equals 0. So I get x squared minus x minus 6 equals 0. And honestly, they shouldn't be any harder than this to factor on the exam. They don't give you super hard ones because that's not what they're testing. So you get x and x. What are the signs going to be? Plus and minus. I just put them in. And now factors of 6 that will give me 1, 2, and 3. Who goes with the minus? Okay. Now, if you, my daughter went to U of M. She had to solve something like that. She could just do it pretty much in her head. And she lost half her points. They wanted to see this step. We graders don't care if we see this step. I'm just telling you what they're going to expect in college. So what's x equal to? 4. And those are my limits of integration. Negative 2 to 3. As far as I'm concerned, just set them up. If you need practice integrating, then practice integrating. No. Can you just look at the graph? No. I didn't know where those were. And generally, it's going to be an e to the x equal to something algebraic. It will be. We're going to do the first problem off your packet. Is that okay? Last problem. And I want to go through the other kind of area problem. You would integrate that. I don't want to integrate it. This is going to be, no, we're not. We don't need a calculator for this one yet. Okay, find the area between the square root of x and this line and the x-axis. Well, here's the problem. Guys, if I slice it vertically, I get the curve here minus 0. I get that all the way until I get up to this point. Then I have to do what? I have to do the line minus 0. How many integrals do I have? 2, which I can do. So I can integrate this one, y dx, and then I can integrate the other y value, y2 dx, and then I have to figure out where they integrate from. So this is x starts at 0 and goes to x equals a. We'll call that x equals b. So it's 0 to a, then I have to do a to b. Sometimes you have to do 2 integrals. There's no way around it depending on how they phrase the question. But I can actually be a little more clever than that. I can slice it the other way. You know, you can slice a cake vertically. If you're like me, you just like the filling. You can slice it horizontally and just take the filling. So we can slice this way. How many integrals will I get with this one? I'm just going to get 1. What's the differential now? Delta x or delta y? That's delta y. We can slice them vertically or horizontally. You'll run into it in the packet. Okay, so that's delta y. Now, how do you find the height? So the base equals delta y, and the height, remember, it's not going to be y1 minus y2. Which coordinate am I going to look at here now? X. So that's x1, and that's x2. Does order make a difference? Yes. Which one's bigger? The one further to the right has bigger values. So it's got to be the big one minus the small one. So we're almost there. So we do have to do a little bit of work. We will integrate this with a dy, and we will do x1 minus x2. The dy tells me right there that I want y's. I don't want x's in there. So you know what I have to do? I have to solve these equations up here for x in terms of y. So I have the square root of y equals the square root of x. How would I solve for x in terms of what? I don't want square root of x. What's the opposite of square rooting x? Squaring. I don't need absolute value because I'm squaring. So this is y squared is equal to x. What's the other one? The other one is y equals negative x plus 6. So I'm going to subtract 6 from both sides. And because I have negative of x, I'll divide by negative 1. So x is equal to 6 minus y. So I have this one, and I have this one. So we can put them in here. Now, which one is further to the right? The line or the parabola? The line. So the line is 6 minus y. Matches my differential. And then it's minus the other x value, which is y squared. And it's dy. The order makes a difference. If you integrate, if they say set up and do not integrate, there's no way for you to check, unless you use a calculator or something. Now, when I do these limits of integration, which letter do I want, x or y? I want the what? The y values. That's why the differential's so critical, because it tells you what your variable is going to be. That can never change. Once you figure out what your base is, that determines everything else. So guess what I have to do? I have to find out where these two curves intersect. What's the smallest y value here? 0. And it's going to go up to the y coordinate here. It's going to keep adding in those little slices. So it's going to go to 0 to wherever they intersect. Well, I need to find out where these intersect. X is equal to y squared, and x is equal to 6 minus y. What's true about the x coordinates where they intersect? Are they different or are they the same? They are the same. So if the left side's the same, then the right sides are the same. So y squared equals 6 minus y. This is all algebra. Set up the integral was the only thing, and pretty much that's geometry. Knowing it's an integral is the calculus, and then integrating it. Okay, you always said everything equal to 0. I want everything on the left. I don't like my y squared to be negative. So it's y squared plus y. I change this over there, it becomes positive. And 6 that I put on the other side becomes negative. It's always equal to 0. You cannot do zero product property in that, or square root it. It's not going to make any sense. To solve any equation, you always set it equal to 0 and look for the zeros. So it's going to be y and y, and signs are plus and minus, right? And what numbers do you want? Okay, so what goes here? Plus 3 minus 2. So the zeros occur at y equals what? 2 or negative 3. Only one I'm going to use because I only have that one intersection. The other intersection, because this is not a function mode, if you were to take the other piece of that parabola, would come back and intersect over here. So what do I want for my upper number? Do I want 2 or negative 3? I want 2. There you go. And that's all there is. Highly geometric. So let's at least get started on number 1. I don't know why we're behind, but we are. Oh, wait, no, we're not, because my clock's on. So I'm going to draw number 1, very first problem. That was not what I wanted. Oh, there it is. We're only going to do part A. Whoa. And then on this one, actually we can look here. On 1 through 10, don't do the integrals. Just set them up. But this is 1 through 10. There's one of these you're going to slice horizontally. Which one? 4. I don't know how to do it this way. Also, the differential is dx here. I can't solve for y in terms of x. I have no idea how to do that. Okay. Anything more there? No. And so now I'm going to draw this thing, and we could graph it on our calculator, and, well, if we don't get it done today, we'll get it done. Now, be careful. It does not touch the axis at 1. There's 1. Guess what? I don't know where that is. You guys know where it is? No. Which way do you want to slice this, vertically or horizontally? If I do it horizontally, then I'll have this line minus that, and then this line minus that one. So I don't know how to do that. I get 2 integrals. Sometimes you want to do it that way. How about if I do it vertically? Then it's the curve minus the other curve. Okay, what is the top curve? That's y equals the square root of x. And notice they called them y, and they didn't call them f and g, so you're going to have to actually write it out. And then this is e to the minus 3x. And they're going to give you either logs or exponentials. You cannot solve when these intersect. You cannot solve it by hand. Impossible. Okay, so the area is equal to the base times the height. The base is delta x or delta y? Delta x. That's the first thing I do. And then I just want to subtract the 2 y coordinates, y1 minus y2. I'll worry about what they are in a moment. y1 minus y2. So the area, I'm going to add them all up. So that's the integral of y1 minus y2 dx. And I have to integrate on the x's. You see why it's the x's? Okay? From this x coordinate at this intersection point. We're going to run out of time to get that today. But to that one. So we want to integrate. Let's call that a. How about that? And you may do that on your paper as well. Call it a, but you're going to have to tell the reader what it is, and you include all the decimals. And we're going to go from a to 1. And all the decimals. Now, I don't know which one's y1. If you clearly label it, I'm okay with that. So we're going to integrate from a to 1. Which one's y1? Square root of x, isn't it? Minus, and then that's e to the minus 3x. And this is very doable by hand, by the way. But you were given a graphing calculator on this problem, I believe. It says right there right above it, it's a graphing calculator. Because you can't solve for where they intersect without a calculator. So that's what our job is going to be. All you have to do is find a, and then you integrate it with the calculator. And I think we're out of time. But we will finish this. We'll start off with this one tomorrow. You come in with an answer, that'd be nice. So your homework is, if you want to set up those integrals in the book, those are actually pretty good. And your homework's to be working on this. You will not get it all done for tonight. That's just fine. Because otherwise you have nothing to do on Thursday and Friday. Okay, time to go.